All right, so this is going on page 145 when we're done. So here's what I want you to draw over with a color or something before we talk about what we're actually doing. If you look at, so this is a polar grid, okay, but if you think about this as a rectangular axis, then this would be your x-axis, this would be your y-axis, and it's fine to still kind of visualize it as that, because remember, the points end up in the same place, so you can kind of have an idea of what's happening. However, there's no x and y-axis on this actual grid. The axes are totally different. So from the center, just the positive part of the x-axis, this right here, this is the polar axis. I don't think I really ever said that. We just started, I can't spell. I think we just started doing it, but I wanted to make sure that you knew that. So that's the polar axis. And then it's going to be kind of hard to label the other part, but the points, actually we'll just label it. We'll say point A. Okay, you don't normally label it, but I don't know what else to do that. A is the pole. It's not always called A or anything. I just think putting another arrow in there will make it confusing with everything else. So what you actually have as a blank grid truly is just the pole and the polar axis, which just looks like a ray, but you'll never be given it that blank. But you can just think of it, sometimes you will just be given what looks like an X and a Y axis, but this is truly your only axis. And then the origin that we're used to calling the origin is the pole. Does that make sense? That's why I say like go through the pole. Just want to make sure that the terminology, you knew what I meant there. Okay? Are we good? All right, so now it says graph each of the following on the polar graphs below, and we're going to describe what they are. All right, so this, like we just said, this is an equation. Okay? It's not something like, not a point that I go and plot. So if I just have r equals 3, do you know what that's going to look like for a polar graph? What is it? A circle. And what do you know about the circle? The radius is 3, right? And right now, you may not know why or anything, but right now it's centered on the pole, okay? Because if that's all you have is a radius, it's always going to be centered at the pole. So that's like your center. And then the radius is 3. So from the pole, I can go to the right 1, 2, 3 and make a point. I can go up 1, 2, 3. Oh, why am I plotting all of them? Dang it. Okay, 1, 2, 3. And then to the left. And then down. So you get at least 4 points plotted. 5 if you count the center. It's good to put it there so you know where it is. And then this is a whole lot easier to graph on here right now than it is on a rectangular grid because you actually have a circle to follow. And it doesn't have to be dotted, but mine would not even with the line there, would still not look like a circle if I didn't. So dotted is fine if you're just trying to get a shape. Okay, we good? So now, converting this, so we're going to convert and we're going to describe. If you just know what it is, you don't have to do any fancy conversion, although this isn't going to be that complicated anyway. You know what the radius is and you know what the center is, so you should be able to write the equation of a circle based on that. But when things get a little bit different or you're not sure what to do, remember all of this can be taken back to just straight substitution. To get from polar to rectangular, what do we substitute in for r? Square root of x squared plus y squared. And then that equals 3. So then I square both sides and get x squared plus y squared equals 9. That's my rectangular form of the equation. And I could have just, like I said, done that if I know how to write the equation of a circle, because my center is at 0, 0, my radius is 3. Okay? So to describe it, we're going to say that this is a circle centered at the pole, okay, and with radius of 3. Okay, it's got to be able to have some words that go with that. We all good with that? Any questions? Okay. So let's try this next one. So here I just have theta equals pi fourths. So again, looks like a statement, but it is an equation. So do you know what this one's going to look like? Yeah. what is it? It's going to be a line, right? And we know where it goes, because this means that theta is always pi fourths, right? So I can come over here. I'm going to use my little cheese. And then here's pi fourths. Your ID badge, by the way, which is supposed to be around your neck, it makes a great straight edge. You just plop that up on the table, and you are good to go. And it looks like this. So we are going to describe it, and we are going to convert it. And if you can convert without doing work, that's okay. If you can understand what's happening, well, I think we'll convert, and then we'll talk about how we would know. I just didn't want that to be the only way I taught it to you, otherwise you can't do the rest of them. We know it's a line. Does it have a y-intercept? Well, yes, that's a dumb question. Sorry. Of course it has a y-intercept. So it has a y-intercept. In the rectangular coordinate plane, what is the y-intercept? 0. So what my brain was really thinking was, if I put it in y equals mx plus b, there's no b to put in there, right? That's kind of where I was going with that. So it's going to be y equals something x, like whatever the slope is. So if you don't just know what it is, then we can just substitute, just like we did on the rest. So for theta, what do I substitute in for theta? Tangent inverse, good, of y over x equals pi fourths, right? So then I take the tangent of both sides, so y over x is equal to the tangent of pi fourths. And maybe sometimes you don't need to necessarily write that, but in your notes I think it's good so you know where this stuff magically comes from. What is the tangent of pi fourths? 1, right? So y over x equals 1, which means y equals x. This is not just a line, but it's a special line. What's it called? The what function? Parent function. It's the parent function, okay? So here's what we know. If you know that it passes through the pole, you can put it in y equals mx plus b, and you don't have to worry about b. All you really are worrying about is the slope, okay? And the slope of the line is going to be whatever the tangent of that angle is. Does that make sense to you? Because of the way you have to work it out. Plus, you know that this is a 45-degree angle. And so if x is 1, y is 1. If x is 2, y is 2, that sort of thing on the rectangular coordinate plane. So here, let's describe it. And we're going to say that this is a, oh, sorry, I was making sure I was doing all the stuff, but then I was looking at the wrong one. So this is a line, oh my God, I did this one wrong, through the pole. With slope of 1. So here's one thing I want you to add to both of these, is that on here, when you have just theta, there is no r in your equation, then the radius can be anything. Does that make sense? It's for all r's, that's what theta is. And then on that first one, if you only have an r and you have no theta, then theta can be anything. So those are the ones that you can kind of reason through maybe sometimes instead of just doing the substitution, but you can always fall back on that substitution to make sure that you're wrapping your mind around it correctly and it makes sense to you. Okay, we all good with that? All right, so now let's look at this next one. Do you know by just looking at that in polar form, like I know what that is? Does that look like something because the only ones we really did were, hey, that has to be a line and that has to be a circle, were the ones we did on the front, right? So you'll get to a point where you can do that pretty easily, but instead of trying, what we could do is we could make a t-table and we could pick some values and plug them in and find them. And we're going to have to do that on some of the graphs that we do. But if we can easily convert it, you can convert it and then think about it in the rectangular form. So let's start by converting this one. Can I substitute something in for r sine theta? Y, right? So this is y equals 2. Bam. It was that easy, right? So it looks all complicated in polar form, but it's really just y equals 2. Well, y equals 2 is a pretty easy line to graph. Would you agree? But it's a pretty easy line to graph on the rectangular coordinate system. Because over here, if y equals 2, first of all, is that horizontal or vertical? Horizontal. Okay. So it is a horizontal line, and it goes through y equals 2, right? Well, I can plot one of the points. I can start here, and I can go up to 1, 2, bam. I know that that's a point. And then I know it's a horizontal line, which if I had a rectangular coordinates plane, I would be able to do that. But here, it would kind of be guessing. So what I want you to do on these, where you have to kind of guess on some of the other ones, we're not going to make a T-chart of 1,000 points or anything like that, but you are going to have to do at least 2. But the good news is you get to choose them, okay, just like the other stuff. So you choose the easiest ones. You know, in the rectangular system, a lot of times we'll try, like, let's try 0, 1, and 2, because those are the easiest ones to plug in. Well, it depends on what you have, which one's easier. So we're going to have, instead of an x, y, we're going to have r and theta. Now, in the rectangular system, we usually choose x and find y. Not always, but that's what's mostly done. And when you graph, you usually do the x and then the y. Well, on the polar coordinate system, we usually do the theta and then the radius, even though you can do it the other way. Same thing goes here. Would it be easier to pick an r and find theta, or pick a theta and find r? Which one would be easier to find? Wouldn't it be easier to evaluate the theta, like the sine of theta, and figure out what that is, than picking an r and figuring out what theta is? So let's think about this. I only have to find 2 more points. And, well, I technically only have to find 1, because you only need 2 points to make a line, but we're going to find 2, because it'll be easy. So you think about, I want one over here. Well, which one of these 3 has the prettiest sine value? So you're thinking about your little hand trick, because your options are either 1/2 square root of 2 over 2 or square root of 3 over 2. So which one's the prettiest of those 3? 1/2. Okay, so which one of these angles has a sine value of 1/2? Pi 6, right? So I'm going to choose as my theta pi 6. That's how I'm going to decide, because the sine of pi 6 is way better than the sine of any of the rest of them, right? Okay, is this just to give to her? Okay, thanks. All right, so then I'm going to substitute it in. And you don't necessarily always have to show all your work on this. I'm just going to do that here so that you can see what's happening. So this gives me r times the sine of theta, which is 1/2, which is equal to 2. So what does r equal? 4, right? Pretty easy. So that's where this 4 right here comes from. So I can go to pi 6. And then my radius is 1, 2, 3, 4. There's another point. So now that I have that, what is the next easiest one to pick? 5 pi 6, right? So if I do 5 pi 6, what's my answer going to be? 4, right? Because we already know it's a line. It's just another point I can get out there. So 5 pi 6, and I can go to 1, 2, 3, 4. And then I have something that I can draw my line through. So, otherwise, if you just plot one point, you're kind of guessing is the actual angle of the line. And again, technically you only need 2, but you can get 3 very easily because it's all reflective. Okay, we good with that? All right. So, we have, this is a horizontal line. And where y equals 2. There's really no other way to put anything about the angles or anything on that without having a, nah, that's it. It's a horizontal line, y equals 2. So you kind of answer that one twice, because you can't say that it goes through an axis, because that's not an axis. It goes through lots of angles. It goes through lots of radii, so it's not as simple as just a horizontal line in the rectangular coordinate plane. We good? Any questions at all? All right, let's look at the next one. All right, r cosine theta equals -3. All right, so what can I substitute r cosine theta with? X. So I get x equals -3. So I can already describe it and just say that it is a, what kind of line? Vertical line. Where x equals -3. Now, if this was x equals positive 3, I could say that it passes through the polar axis. But it doesn't because it's only the positive side of x. All right, so x equals negative 3. That means I know that I can come over here and go 1, 2, 3. Well, there's 1 point, and then it's a vertical line through that. But again, to draw it accurately, because we want to get, as accurate as we can anyway, we need to have an idea of what to do here. So I'm going to do my little r theta thing here. Well, on this one, I have cosine. So which one is the easiest to do the cosine for? What's the reference? Let me ask it that way. What's the reference angle that's easiest to do cosine on? Pi thirds, right? Which means it would be 2 pi thirds. It's fine to answer it that way too. So 2 pi thirds is going to be my theta. So that means I'm going to have r times, what's the cosine of 2 pi thirds? Is it 1/2 or is it negative 1/2? Yeah, I got to be careful with the signs. Negative 1/2 equals negative 3. So what does r equal? 6. So what's another theta I could pick so I could get another point? I know it's going to be vertical, so 4 pi thirds, good. And 4 pi thirds is going to have to be at 6, right? You don't have to do any work there. Now this goes off your graph a little bit, and I knew that, but it's okay. So 1, 2, 3, 4, 5, just kind of guesstimate as to where it is, even though the whole point was to be more accurate. 1, 2, 3, 4, 5, 6. And then we can draw in our line. Hopefully mine actually hits my points. There we go. All right, everybody good? Any questions? All right. Now, not every polar graph or polar equation that we have, we're going to be able to convert to rectangular. Like they all can be converted, but that's not going to be something we're even capable of at this point. But the ones that we're doing today, we can. So we're not going to have to do straight tables. Get off your phone. Straight tables today. We'll have to look at that tomorrow. So here I have r equals 6 cosine theta. So is this going to be something I can just substitute something and bam, have a line? No, right? Because I don't have anything to straight substitute. I do have something to substitute for r. I don't have anything to substitute just for cosine of theta. So what did I do in this situation? What do we do? What has to be with my cosine for me to be able to substitute something in? The r. So I need an r with it, which means I have to multiply both sides by r, right? So this is going to give me r squared equals 6r cosine theta. So now I can substitute for the r squared and I can substitute for the r cosine theta, so I'm good. So what do I substitute for r squared? X squared plus y squared equals 6 what? X. So what is this going to be? A circle. Is it going to be centered at the origin? No. Okay. So I need to figure out where it is centered. So I'm going to move my 6x over. So x squared minus 6x. I'm going to leave a space. This will be plus something. Then plus y squared equals something. So I've got to complete my square and replace some. What goes here? 9, which means 9 goes here as well. So then I can take this, and it becomes x minus 3 squared plus y squared equals 9. All right, so our center in the rectangular coordinate plane is where? And yeah, so if I'm going to graph this in the rectangular coordinate plane, where's the center? 3, 0. Good. Yeah, that's something. That's why you want it in this form, so you can just pull the center right off, and the radius is 3, right? So that's going to help us here get it on here, and then we're going to go back and describe it. Do you have a question? Okay. So I'm going to go to 3, 0, 1, 2, 3. Okay, and that's my center point. And then I know that the radius is 3. So in the rectangular coordinate system, I can get 4 other points real easily. I can just go left, right, up, and down. I can go left and right pretty easily here. I can go left 3. Here's a point on the circle. I can go right 3, which again, I know is throwing us off, but it's right about the 0. To kind of guess. But I don't want to have to guess on the other ones. I think it's actually like right on the 0. I don't want to have to guess on the other ones. I want to know what they are. Well, here's what I do know. I do know that this length would be 3 and this length would be 3. I just can't count that way over here. But if this is 3 and this is 3, if I was to connect them, what's the angle there? What kind of little triangle would I get if it was a 3 and 3? It's a special right triangle. Isn't it a 45, 45, 90 triangle? Which means what I know then, and what will happen every time with these circles when you can hit the pole right here, is that if this is 3, since I'm going up 3, then the angle that those would make would be 45, which would be pi fourths. So I know that somewhere on that angle, I would have that other point. I mean, you could pick random angles and get some other points and plot 1,000 of them or pick some other ones, but it's really easiest to get those quickly. So we'll look at that and we'll do our r and our theta. Okay, so we're going to pick pi fourths. Now that's not ideal to find the cosine of, but it's really not that bad, right? So what is the cosine of pi fourths? Square root of 2 over 2, right? So that means that our radius is going to equal 6 times the square root of 2 over 2. So what is that going to give me? 3 square root of 2. So this is 3 square root of 2, which I really kind of need as a decimal to approximation. So what did our square root of 2, what do we estimate that at? About what? 1.4. So 3 times 1.4, it's like 3 times 14 is what? What's 3 times 14? 42. So this would really be about 4.2. So that I have something to graph on there. Right. So I can go to pi fourths and go 1, 2, 3, 4.2-ish, and there's a point. So what's the other angle you think we'd use? 7 pi fourths. And what do you think the radius is? Or the r would be? 3 squared. It's actually still positive. Yeah, it would still be positive because negative would shoot me through there. I could use the 3 pi fourths and do a negative r. It's the same thing. But so again, that's about 4.2. It just gives me something I can graph. So I'm going to go here, and it would be 1, 2, 3, 4.2-ish. So now you have your 4 key points, and just like on the rectangular one, you just got to do the best you can to make it look like a circle. Like so. All right, we're good? Now we got to describe it. So this is a circle with the center on the polar axis and the center is how far from the pole? 3. So then it is 3 units from pole, and radius is 3. Those two numbers won't always be the same, because if the whole circle got shifted to the right, then the radius would be 3, but the center would be 4 units from the pole. So it's kind of a coincidence that they're the same. So I know it seems redundant, but that's why it's that way. So we know what the radius is, and we know that the center is right here, and it's that many units from the pole. Okay, we all good? Any questions? I want you to work on converting this one. I'm going to go check roll, and then we'll talk about it. Okay, what goes here? 9/4. Very good. Because all you have to do is take half of this and square it, but we don't want decimals in there. Fractions are way easier to square than the decimals are, for sure. Oh, I should say plus. That's 9/4. Everybody good so far? So then that gives me x squared plus y plus what? 3 halves squared equals 9/4. Everybody with me so far? Good? Okay, so on the rectangular coordinate system, what's the center? 0, -3 halves, and the radius is what? What's the square root of this? 3 halves. So I can come over here, and I can go to 0 and then -3 halves, which is like 1.5, right? About right here. That's not really how you graph a point on the polar axis, is it? Because that's in rectangular form, but we don't need to change it to polar form to be able to plot the point. If we did, then the radius of for the point, that ordered pair would just be 3 halves, comma, 3 pi over 2. But we don't need to go through that because they are in the same position as the rectangular coordinate system. So when you're on an axis, those are super easy to graph. They're also super easy to convert without the work because, you know, you'd rotate and then you'd go 3 halves, right? Okay, so we have that point. Now we know that the radius is 3 halves. So I can use that knowledge without having to think in polar to get 2 more points. I can come here and here, because there's my radius of 1.5, right? Then I need to find 2 other points. Well, I'm thinking I still would like to use the 45 idea, right? Because I would come to the right. So this would be a little 45, 45, 90 triangle here, which means I'm going to use 7 pi fourths. So when I substitute that in and I get r equals -3, well, pi, what's the sign of pi fourths? Square root of 2 over 2. And then in the fourth quadrant here, it would actually be negative square root of 2 over 2, right? Which means my radius would be 3 square root of 2 over 2. All right. So that means that that square root of 2 is about 1.4, right? 3 times the 1.4 was what? 4.2. So I divide that by 2. It's about 2.1. So it's technically this, but really to be able to do it, 2.1 is about what we're graphing. So at 7 pi fourths, I'm going to go to 1, 2, and a little bit more. Probably a little too much more. Then my other angle is going to be 5 pi fourths. And it's going to be also about 2.1. I don't even have to do any work because everything's so symmetric. It's really kind of nice. 1, 2, and then a little 0.1 there. And then we just do the best we can to make it look hopefully not too egg-like or football-like or squished, but an honest attempt is fine. And again, they don't have to be dotted necessarily. It's just way easier for me to do it semi-well with dotted. Are we all okay with that? Any questions? So these are going to be the type of graphs that you could do without converting. Oh, we need to, I'm sorry, I didn't explain. This is a circle, okay, with center. And I can't say that the center is on the polar axis because it's not. It's on 3 pi halves, right? On theta equals 3 pi halves. And so it's the circle with the center on theta equals 3 pi halves, 1.5, or you can say 1.5 or 3 halves units from pole. and radius is 1.5. We good? There will be some really cool things that we graph, and we'll graph some things on the calculator too so that you can see them. But they're going to require us to do some table things because we're not always going to be able to just convert. So these simple circles where they're on either a quadrantal angle or the polar axis or the simple lines are what we can do and convert and kind of wrap our minds around before we get too crazy. Okay? Any questions? We good?